Alright, hello everyone. Welcome to week 5 sensitivity analysis, exploring uncertainty for optimal decision. So what's the learning objective of this week? We're going to cover some basic fundamental of sensitivity analysis, including the purpose of sensitivity analysis for decision making. And also then after that, we're going to cover two typical methods, one-way and two-way sensitivity analysis. And by the end of the lecture, we should be able to use the Google spreadsheet or similar software tool to perform one-way and two-way sensitivity analysis. Alright, so let's start with the question, why sensitivity analysis? Some of the analysts mistakenly stop the analysis after a preferred option has been identified. So as we discussed before, we use the proactive, and by the end of the step number 3, we should be able to identify the optimal decision based on our expected value calculation. However, this is not the point to end the analysis, but it's a starting point of real understanding of what leads to the choice of one option over another. Or it's a time to investigate how the conclusions are sensitive to some of the input. Because we do the estimate and also we do the research in the literature in order to provide the value for some of the uncertainty parameter in our model. So we should be skeptical about the number used in the analysis. And one of the very important questions we ask, that is the conclusion different if the estimated number were different? Because if the we knowing that the estimated values is not exactly in reality, so the calculation based on that values, and if we with the small change in that number may change our conclusion, so our conclusion or our recommendation may be a concern. So the sensitivity analysis gonna be provide us the methodology and so the tool in order to find out the answer for such kind of question. Right, so roughly the sensitivity analysis can be defined as a process of changing the input parameters until the output or conclusion is affected or changed, and that we call reversal or point. So reversal point defines the value of a parameter at which our decision is reversed. So if you pass over such values, the decision is gonna be changed from one to another. So that we call a reversal point. In other words, the sensitivity analysis can be a process of see a small difference in the estimate will change our conclusion or not. So by varying the values of a variable within a plausible range, and we can observe either our decision going to change or not. Alright, so before going to detail the technique in order to perform the sensitivity analysis, let's go back to revisit one of the example we had before, we call PE example. So the PE example in which two lecture gonna consider two options for treating the suspected PE patient. The first one we call a AC anticoagulation versus the other option is no AC or no anticoagulation treatment. So by doing the or studying the literature, we be able to estimate the probability of the PE. In our example in lecture 2, we use the probability of the PE is 0.19. And using that parameter, we calculate the expected value of survival probability of the AC option equal 0.99 or 99% compared to the no AC option, that's 0.95 or 95% of survival. So based on that assumption, P equals 0.19, we be able to conclude that the AC option is the better choice here. So from the line of sensitivity analysis, from the line of the sensitivity analysis, we want to ask a question: what if the probability of PE or PPE is lower or higher, and at which value our decision change? Because based on the literature, we have the value of 0.19, but in reality, maybe the actual values could be different. So if the estimated value of PE change slightly, and our conclusion change. So our conclusion gonna be a concern, because that gonna be a very sensitive to the input, where the input is uncertainty. And with small range or small change, that change the conclusion of recommendation treatment, we need to be very careful with such kind of a scenario. So before we do the sensitivity analysis in a more specific sense, that we call a treatment threshold. So treatment threshold defines the probability of the disease at which the expected value of treatment and no treatment are exactly equal, and neither option is clearly preferable. So as we discussed before, when the value of the probability of PE equals 0.032, at this point right here on the graph, you can see that the probability of the survival of the AC scheme and no AC scheme gonna be the same when they intersect with each other. So in this case, the treatment, either treatment method gonna be make no difference. And with that said, when we have the value, the probability PE less than a 0.032, the no AC treatment scheme gonna be preferred, where the values of the probability of PE greater than 0.32, the AC scheme is preferred. So in this sense, we can say that the treatment threshold analysis is going to be a special kind of sensitivity analysis. All right, so next we talk about the technique to perform the sensitivity analysis. We have the one-way, two-way, and n-way sensitivity analysis. So one-way sensitivity analysis is the typical analysis usually we're going to perform in most cases. In this method, we have the value of one probabilities will vary, and while the other value of probability and outcome remain constant. So it means we change only one parameter at a time, and we observe the outcome. Two-way sensitivity analysis, we can observe the effect of simultaneous change in two variables at the same time. Example here is that what would be the threshold PE if the risk of the fatal recurrent PE without anticoagulation were to be lower than the initially estimated value of 0.25. So in our example before, in lecture 2, we have the PE equals 0.19 and the fatal recurrent PE equals 0.25. And with that assumption, or with that estimate, the recommendation treatment is the AC method. Now the question is that what if both of the values is not the same as the estimated value, and PE not equal 0.19 and fatal recurrent PE is not 0.25? Do we change our recommendation? So that's gonna be a two-way sensitivity analysis. So varying two variables simultaneously, a graph showing the combination of the value of the two variables, a treatment with the anticoagulation, withholding anticoagulation in the graphical right here. So we see that the values of the domain of the AC scheme gonna be the gray area, and the no AC scheme gonna be the black area right here. So we can see that if the value of the fatal recurrence 0.25 right here, and the PE gonna be 0.19 right here, so the value gonna be around right here. So in this case, it's falling into the area of the AC. So it means AC scheme gonna be or AC method, treatment method gonna be preferable. For example, if the recurrent PE fall all the way right here and the same value of the probability of the PE right here. So for example, that's right here. It means the values of the outcome falling into the no AC area. So no AC treatment method can be preferable. Right, so we can discuss some of the methods in order to perform our two-way sensitivity analysis in next few slides. The next method we call n-way sensitivity analysis. So by doing or by varying the n variables at the same time and observe the outcome of the conclusion, we have the n-way sensitivity analysis. So this is obviously very complex, and the most of the time we not be able to perform n-way or all the parameter change at the same time. The typical scenario we use this analysis can be applied to scenario with a very different setting and different type of patient in our decision problem. Okay, so within the scope of this lecture, we're going to focus on one-way and two-way sensitivity analysis. All right, so what the step we need to do for the sensitivity analysis? Consider sensitivity analysis of a single variables or one-way sensitivity analysis. The other analysis, two-way and n-way, are performing the same manner. Step number one, identify the key variables. The identify variable whose values are uncertain and which may affect the outcome decision. For example, in our previous example, the probability of PE or the probability of the recurrent PE or the chance of fatal HAM and so on. So by constructing our decision tree and by looking at each of the branch or each of the path of our decision, we can see that the which parameter gonna be uncertain, and the values of the parameter changing may affect the outcome decision. Step number two, identify the plausible range of the parameter or the variable values. One of the methods we can consider, or one of the typical range we can consider, that 95% of the confidence interval or a justifiable range, smallest to the largest values of the parameter. Sometimes we are looking at the 2-point estimate for the calculation. One is for the best possible scenario and one for the worst possible scenario. So you can think about the expected values. One of the point where the expected value of that specific option going to be largest, and one point where the expected value of that option going to be smallest. Okay, we can see some of the example later on. Step number three, vary the values of the variables, starting with the changing a single estimate at the time until the conclusion are reversed or changed. Or we can vary the value from the smallest value in the plausible range to the largest value of the plausible range, and we observe the outcome. Step number four, we interpret the result. So by looking at the result, one of the key we want to observe is that do we see the change in our recommendation or the decision. So for the whole range, we don't see any change, or we we see some of the change, but the reversal point very far away from the estimated point. So in that case, we can interpret that our decision pretty confident or safe, not a big concern, because the range or the difference from the estimated to the reversal point very far away. So our decision gonna be likely gonna be the same if we slightly change the estimated values. Right, so we're gonna see all these steps in our example in the next few slides.